My dear students, have a nice day. For this week, we will have new topic for general math and a continuation for statistics. So for general math, we will discuss rational function, then rational equation, and rational inequality. For statistics subject, we will discuss the z-scores, interpreting z-scores, and we will plot it into the normal curve. Alright. Okay, for this week we will discuss first rational function. It is defined as a function which is in the form of u of x is equal to p of x all over r of x, where r of x must not be equal to 0. Because the moment the denominator is equal to 0, the whole function is said to be undefined. Now, in this topic, we will find the domain. We will also find the range. And after this, we will sketch its graph. Now, in sketching its graph, we have to locate first the following: the horizontal, asymptote. We have also the vertical asymptote. We have to find its x-intercept and also the y-intercept. Right? So, first of all, we will find the domain and the range of every rational function. Start directly to the example. We have f of x is equal to 2x minus 1 over x plus 4. In finding its domain, just set the denominator to 0. Set denominator to 0. Thus we have x plus 4 is equal to 0. Then transposing this 4 to the other side, this becomes x is equal to negative 4. And so, from the definition, your denominator must not be equal to 0. So if we try to substitute this value of x here, this becomes f of negative 4 equals 2 times 4 minus 1 all over negative 4 plus 4. So this becomes 8 minus 1 over 0. Now, the moment your denominator is 0, the whole function is undefined. Therefore, your domain, the domain of this function, is that should be all values of x excluding negative 4, meaning all integers can be used as value of x. X is the domain, but not this negative 4, because if we include negative 4 as value of x, the whole function is undefined. Okay, that is your domain. Now, after finding the domain, since it is said to be the first elements of the ordered pair, then after substituting the values of x to the function, you can already find its range, because range are those all values of y. Okay. And how about asymptote? What is this asymptote? There are two asymptotes, the horizontal and the vertical. These are lines or imaginary lines that limits all of the curves of the rational function, or the curve of the function will not go or pass through this asymptote. If we have a Cartesian plane, horizontal asymptote may be found below the x-axis or can be found above the x-axis. Your asymptote must be parallel and of the same length of the x-axis. On the other hand, your vertical axis is either to the right of the y-axis or at the left side of the y-axis. Now, example, if our asymptotes are located here, if our horizontal asymptote is located here and your vertical asymptote is located here, it acts as a limit of the graph. Let's say the graph of your function is here. Okay, it will be extended. It tends to be closer and closer and closer to the asymptote, but it will never touch it. It will never touch the asymptote. Or if we have here, it will be extended up to infinity and will tend to be closer and closer, but will never intersect those asymptotes. Right? Now, how about intercepts? Intercepts are if asymptotes are lines, intercepts on the other hand is a point, meaning it is a combination of x and y values, and it is located at the axis itself. So in this case, your x-axis is found here, right? That is on the x-axis, and your y-intercept is here. Now, our task is to find this asymptote and these intercepts. Using the same example, we will find its asymptotes and intercepts in order for us to sketch the graph of this. On your textbook, on page 77, you can find there the ways on finding asymptote. So if we are to find the vertical asymptote of this one, of this function, just do what we do when we are to find the domain. Set the denominator to 0. Just set the denominator to 0, and then it will give you x is equal to -4. Therefore, this is your vertical asymptote. Therefore, your version we will -1, -2, -3, -4. Therefore, your vertical asymptote is located here. How about the horizontal asymptote? There are 3 suggested conditions on how to find the horizontal asymptote. We have n is less than d, we have n is equal to t, we have n is greater than t. What is this n? N refers to the exponent of the numerator. This is n. While the d refers to the exponent of the denominator. Now, in this case, if n is less than d, if the exponent in the numerator is smaller than the exponent here in the denominator, your horizontal asymptote is located in x-axis, or if here x is equal to 0, right? Now, if your n is equal to d, like this, the exponents are the same. So to find the horizontal asymptote, just get this one, the value of this a over b. What is your a? Your a is the leading coefficient in the numerator, and your b is the leading coefficient of the denominator. Yes, we have, in this case, because they have the same exponent, just get their leading coefficient. 2 over 1 equals 2. Therefore, your horizontal asymptote is found at y equals positive 2. Here, 1, 2. The horizontal asymptote is located here. Okay, now how to find intercepts? How to find intercept? Let's move in this area. To find intercept, x-intercept, just set y to 0. So we have 0 equals 2x minus 1 all over x plus 4. Cross multiply, we have 0 times x plus 4 equals 2x minus 1. And then this is already 0 equals 2x minus 1. And then transpose this to the other side in order for us to find the value of x. This becomes 2 negative 2x equals 1. By elimination, we have 2x over negative 2 equals negative 1 over negative 2. Therefore, your x is equal to positive 1/2 or 0.5. Therefore, your coordinate is at 0.5 and 0. Wherein it is found here. Positive 0.5 and 0 here. Okay. How about y-intercept? Y-intercept. Let's try to find y-intercept. We will set x to 0 from f of x equals 2x minus 1 all over x plus 4. We have f of 0 equals 2 times 0 minus 1 over 0 plus 4. Therefore, we have negative 1/4 or negative 0.25. Therefore, our coordinate is at 0. Our point is at 0 and negative 0.25, which is located here. This is 0 and negative 0.25, and this point is 0.5 and 0. Therefore, our graph is here, and then it will be extended here and here, that the moment we extend our x-axis, our y-axis, and our x-axis into this direction, your graph would look like this. And the other half of the graph is here. Okay. This graph is f of x is equal to 2x minus 1 all over x 4. That is our first graph. Okay. On page 78 of your book, you can find there examples from page 77 to 78. We can find there examples on how to sketch the given function, right? Now, as we recap, in order for us to graph a rational function, we need to find the vertical asymptote and the horizontal asymptote. And what are the tasks of this asymptotes? This will act as the limit of your curve, wherein your curve will, as the curve approaches to the asymptotes, it will become closer and closer, but will never intersect or even touch it. Now, how about intercepts? These are the points where your curve passes through. That is all. That is the process on how to sketch a graph of a rational function. And at the beginning of this, I had discussed to you on how to get the domain and the range, and the definition of that domain and range are being discussed long time ago when we have our, I think, our first or second video. Okay, that's all, and thank you. And that is all for this week. I hope you understand the topic, and still, if you don't understand, just try to ask me on your group chats. And by the way, last day I had to meet some of my students here in DMC. I plan to include them in this next discussion, but because of time constraints, we will not be able to do it. So, God bless all of you, and advance happy holidays.